Okay, I'm here in 8.2, day 2, substitution CAMI assignment. We're going to solve this system by substitution. Okay, so let's label the top equation equation 1 and the bottom equation equation 2. The first thing we're looking for is, do we have one of the equations already solved for either x or y? Because that's our first step, right? Solve one of the equations for one of the variables. And so by looking at the equation, I can see that the top equation, equation 1, is already solved for y. I know that y is the same thing as x plus 9. And so what I can do is move into step 2 and substitute, hence the name substitution. I can substitute what y is equal to into the other equation. Okay, so that's what I'm going to do. I'm going to substitute x plus 9 in for y in the other equation. So let's copy down that second equation. It is 3x plus 8y equal to negative 5. I'm going to take this right here. I'm going to take x plus 9 and I'm going to plug it in right there for y. Okay, so I have 3x plus, and remember 8y means 8 times y. So I have 8 times what y is. Y is the same thing as x plus 9. So I'm going to write x plus 9 where y is. X plus 9. Of course, I'll put that in parentheses, right? Do you see how everything that y is equal to, which is x plus 9, all of that gets put in parentheses to show that I am multiplying 8 times all of that. Okay, I'm going to bring down the equal sign and bring down the right side, which is negative 5. Okay, now all I'm doing is solving this equation that now has not 2 variables, but 1 variable. And I'm going to use the 5-step solve equations that we've used for several weeks now. So I'm going to first eliminate parentheses by the distributor property, bring down this 3x term. I'll distribute the 8 to both of these terms inside the parentheses. So 8 times x, that's positive 8x. So I put plus 8x. 8 times 9, that's 72. So I put positive 72, plus 72. Bring the equal sign down, bring the negative 5 down. After I eliminate parentheses, step 2, I combine like terms. I see that I have a 3x and a positive 8x. I know that 3x plus 8x is 11x. Notice how I used shapes to show like terms. So I have 11x. I'll bring down the plus 72, bring down the equal sign, and on the right side I have negative 5. So my variable x is on the left side. That means my numbers, this plus 72, I need to move it to the right side. I undo the addition by subtraction. So I subtract 72 from both sides so that those 72s cancel right there. I'm left with 11x on the left side. Bring the equal sign down. Right here you have negative 5 and negative 72. So I know that same signs, I add and keep the sign. That's negative 77. Solve for x by dividing both sides by 11. Those 11 simplify, and so my x term is going to be equal to negative 7. Okay, now remember, that's not my answer. This is a system. A system has an ordered pair for a solution, and an ordered pair consists of an x value and a y value. Okay, so the step that we just did, we substituted the value that we had for y into the other equation, so that now we have x. That was step 3. Solve the equation for the remaining variable. Our remaining variable was x, and we just solved for x. So now in step 4, we're going to substitute that value for x into one of the equations, doesn't matter which one, so that I can solve for my other variable, namely y. And so since I already know that x equals this, look back at my original 2 equations. I have this equation and this equation. Do you see how this first equation is already solved for y? That means if I put in an x right there, I will add 9 to it and get out the y value. And so what I'm going to do is I'm going to plug my x value into this first equation. It doesn't matter which equation I pick to plug x into. I could certainly pick the second one and I would get out a y. But this one will be much easier because it's already solved for y. So I'm just going to copy this one down over here. It's the first equation. It's y equals x plus 9. And I'm going to plug what x is. X is negative 7. And so I'm plugging that in right there in for x. Okay, so y is equal to -7, since that's what x is, plus 9. Okay, so -7 plus 9, I know that is 2. Okay, so now I have an x value and a y value. And so my final step is to simply write this as an ordered pair. Of course, you put x first and then y because x comes before y in the alphabet. And so in the ordered pair, the x number is listed first, that's -7. Then you put a comma, and then the y value, 2. Of course, ordered pairs are put in parentheses. And so -7, 2 is the solution. We just talked about graphing in our last lesson, 8.1. And we know that if we were to graph both of these lines, what we're saying is that they would intersect at this point right here on the coordinate plane. They would intersect at -7, 2. Therefore, that's why it is the solution. We could check our answer by plugging in the x and y value into both equations. I'm not going to make you do that every single time, but if you would like to know for sure that you're correct, plug the x and y value in, and it should satisfy both equations. All right, number 2, we're going to solve this system. So first thing to look for is, do you already have one of the equations solved for x or for y? Like in number 1, we already had the top equation solved for y. And so we just plug that into the other equation. But here in number 2, we don't already have an equation solved for x or for y. And so what I would do is I would look for the variable that has a coefficient of 1. Look for the variable that has a coefficient of positive 1. Remember, the coefficient is the number in front of the variable, the number being multiplied by the variable. And so in this first equation right here, I call the top equation 1 and the bottom equation 2. In the top equation, this x term has a coefficient of 2, and this y term has a coefficient of -3. In the second equation, this x term has a coefficient of 2, and this y term has a coefficient of 1, positive 1. And so that would be the variable that would be easiest to solve for. You could certainly solve for x or y in either of the equations. That would work. But to make it easier, I would look for the variable that has a coefficient of 1, and I would solve for it. So let's do that. I'm going to copy down the second equation. So I'll put a little 2 and circle it for second equation. It is 2x plus y equals 9. All right, and I'm going to solve for y. That means I need x on the other side, so move this x to the other side by subtraction. Subtract 2x. That way, these two x's will cancel, and y, positive y, will be by itself. So I have y equals. Now, here's another point. In slope-intercept form, when we graph an equation, yes, we want the x term listed first and the constant second. When solving by substitution, it doesn't matter which number you put first. So you can put 9 minus 2x, or you could put -2x plus 9. Either way is correct. It's just a matter of preference. I'm going to go ahead and put 9 minus 2x just to show you that it doesn't matter when solving by substitution. So now I have y equals something, right? I have y equals this right here, 9 minus 2x. And so what I need to do is take this and plug it into the other equation. Remember, this was equation 2 I just solved for. So let's take this and plug it into the first equation. So our first equation, let's copy it down over here. Our first equation, I'll put a little 1 and circle it. Our first equation was 2x minus 3y equals -11. Okay, be sure you copy it down correctly. Now, I'm going to take what y is equal to, this 9 minus 2x, and I'm going to plug it in for y right there. Okay? So, in this first equation, I got 2x minus 3 times what y is. Y is 9 minus 2x, close the parenthesis, right? So for y, I put what y is. Y is 9 minus 2x. Bring the equal sign down, and of course you have a -11 on the right side. Okay, so now follow 5 steps to solve equations. I have this equation with one variable. That variable is x. So let's solve for x. I'm going to bring this 2x down, and I will distribute the number right next to the parentheses. And that number next to the parentheses is not 3. It is -3, and that is the number that I am distributing. So -3 times 9, -27. -3 times -2x. A negative times a negative is a positive, and 3 times 2x is 6x. So negative 3 times negative 2x, positive 6x. Bring the equal sign down. You got negative 11 on the right side. Next step is to combine like terms. You have a 2x and a positive 6x. 2x and 6x is 8x. Bring the minus 27 down. Bring the equal sign down. Bring the negative 11 down. Because your x terms on the left side, you need your numbers on the other side. So undo the subtraction by addition. Add 27 to both sides. That way those 27s cancel, and 8x is equal to negative 11 plus 27. That's 16, right? Same signs or different signs subtract, keep the big guy. Solve for x by dividing both sides by 8. Those 8 simplify, and so x is equal to 2. Okay? Is that your answer? You done now? Nope. You're halfway there. You got your x. Now you need your y for this solution. So you have x. So I need to take x and plug it in to one of the equations. Doesn't matter which one. Okay? How about I plug it into this one? Because it's already solved for y. Okay, so let's take x and plug it in right there. And so y is equal to 9 minus 2x. So 2 times x. 2 times x. And x is 2. So I'm plugging 2 in for x. All right, so y is equal to 9 minus, what's 2 times 2? 2 times 2 is 4. And so y is equal to 9 minus 4, which is 5. Okay, so I have x. X is 2. Y is 5. The final step is to write my solution as an XY ordered pair. So I put the x value first, which is 2, comma, the y value of 5. So 2, 5. 2, comma, 5, and the solution is put in parentheses. All right, so if I were to graph these lines on the coordinate plane, they would intersect at 2, 5. Remember, you can check your answer by plugging in the x and the y value into both of these equations. If I did 2 times 2 is 4, 4 minus 3 times 5, 4 minus 15, that's negative 11. 2 times 2 is 4, 4 plus 5, 9. So yes, this 0.25 works in both equations, and so therefore it is the solution. Okay, last one here, number 3. So looking at the equations, the top one's equation 1 and the bottom one's equation 2, do you already have one of the equations solved for x or y? Like, does one of them say y equals something? Or does one of them say x equals something? Nope. X and y are on the same side in both of these equations. And so the next thing to look for is, do you have a coefficient of 1? Does one of the variables have a coefficient of positive 1? And in fact, the x and the y do in the second equation. And so it doesn't really matter which one you pick to solve for, because as long as you follow the mathematical steps after that point, you will get the same solution. So how about, since in equation 2 we solved for y, how about this time we solve for x, just to show you that you don't, when solving by substitution, you don't always have to solve for y. You can also solve for x when solving by substitution. And so let's do that in this problem, number 3. Let's copy the second equation down. So I'll put a 2 and circle it. I'm copying the second equation down, and I'm going to solve this equation for x. And so I want my y on the other side. So I'm going to subtract y from both sides to move it to the other side. Those y's would cancel, and so x is 9 minus y. 9 minus y. Okay, so I'm going to take what x is equal to. I'm going to take this 9 minus y. I'm going to plug it into the other equation. Okay, so that would be equation 1. So how about let's copy equation 1 down over here. Put a little 1 and circle it. 2x minus 3y equals negative 12. Now, do you see how I'm labeling my equations? Like, this is equation 2. This is equation 1. You might not think that's a very important step, but I think it's a good organizational thing to do. That way you're always aware of what equation is what, because if you don't label things, solving by substitution can get very, very complicated and tricky very, very quickly if you don't stay organized. Anyway, back to the problem. I'm taking what x is equal to, 9 minus y. and I'm plugging that into the first equation for y. I'm plugging it in right there. Okay, so I have 2x minus 3 times y, and I'm not plugging this in for y, I'm plugging this in for x. Remember, this is x equals 9 minus y. So I'm taking this and plugging in for x. So be careful there. I almost made a mistake. 2 times x. So 2 times what x is. X is 9 minus y. So I'm putting 9 minus y in for x. Okay, so 2 times x. Then I have minus 3y equal to negative 12. So now do you see how this equation does not have an x and a y in it? It only has a y in it. And so therefore I can solve for that y. So let's eliminate the parentheses by the distributive property. So that 2 times 9 is 18. 2 times negative y is negative 2y. Bring the minus 3y down, equal to negative 12. Combine like terms. Negative 2y is a like term to negative 3y. So you're going to have 18 minus 5y, right? Because negative 2y and negative 3y is negative 5y. Bring your equal sign down. You got a negative 12 on the right side. Your y term is on the left, so you need your numbers on the right side. So I'm going to subtract 18 from both sides. That way those 18s cancel. And negative 5y will be equal to, what's negative 12 and negative 18? Same signs add, keep the sign. That's negative 30. Solve for y by dividing not by 5. That's not a 5. That is a negative 5. And so once you divide both sides by negative 5, y is equal to negative 30 divided by negative 5 is 6, right? Positive 6. So you have the y value. Now you got to get the x value. So take this y and plug it in right there, right? If x is equal to 9 minus y and y is 6, that means x is equal to 9 minus 6. And 9 minus 6 is 3. Okay, so you have your x value, you have your y value. The last step is to write it as a solution. Your x value first, and then your y value, comma between them, put in parentheses. You can check this by plugging the x and the y value into both equations. What if I put 3 in for x? What's 3 plus 6? 9, right? 2 times 3 is 6. 6 minus 18, negative 12, right? That's if I plug the x and the y value into this equation. Okay, so that's solving by substitution. Be sure you show all of your work and then turn it in.